What's up, scholars? Today we're talking about completing the square. All right, so our goal is going to be converting a quadratic from standard form to vertex form. Convert a quadratic from standard form, which was f of x equaled ax squared plus bx plus c, to vertex form, which was f of x equaled a times x minus h squared plus k, where hk is the vertex. All right, so when we talked about this before, we found the x-coordinate of the vertex. So let's recall. Previously, we found x-coordinate of vertex using the formula x equaled negative b over 2a. Then we plugged the x value in to the equation to solve for y. Then we plugged x value into the function, to solve for y. That's what we had done before in that bonus video. All right, we used this formula, x equals negative b over 2a. That gave us the h value, or the x coordinate of the vertex. We plugged whatever that was into our standard form function, and that gave us the y value of the vertex, or the k. Today, we're going to learn a different technique called completing the square that will allow us to convert a quadratic from standard to vertex form. One of the key components we're going to use in this technique to convert from a standard to vertex form are called perfect square trinomials. Perfect square trinomials. Okay, so an example of a perfect square trinomial would be f of x. Let's say this is an example of a perfect square trinomial. F of x equals x squared plus 4x plus 4. Because if we factor this perfect square trinomial, we will get down to something squared. It's considered a perfect square trinomial because when we factor this, this trinomial, this three-termed thing, trinomial, we will get something squared. It's a perfect square. What will we get when we factor this guy? Well, let's think about our A, C, B tree. A is 1, B is 4, C is 4, so A times C is going to be 1 times 4, which is 4. And our B value is 4, so two numbers that multiply to be 4 and add to be 4 happen to be 2 and 2. So we keep our first term, we split our middle term into these two, 2x plus 2x, keep our last term, 4. Group these two, GCF is x plus 2 times x plus 2. We did a great job because the part in parentheses is the same. That becomes a factor. And the part, or the GCFs that we took out, are our other factor, which, hey, that's the exact same thing, so that must be x plus 2 squared. So the factored form of our standard here is something squared. This is a perfect square trinomial. And this is actually in vertex form, too. This is in vertex form. what would our vertex be? It would be h, right, which is, in our vertex form, remember it's x minus h. So this must have been minus -2 to give us a plus. And it's supposed to be plus k, but there's nothing over here, so we added nothing. So our vertex is at -2, 0. Excellent. All right, cool. So we're going to use this perfect square trinomial concept to complete the square. So let's actually look at a bunch more perfect square trinomials and see if we can see a pattern. Perfect square trinomials. All right, so I'm just going to give them to you. I'll leave it as an exercise to the reader to do the actual factoring if you wanted to. So f of x equals x squared plus 6x plus 9 is a perfect square trinomial. Its factored form would be f of x equals x plus 3 squared. That's one. I could have f of x equals x squared plus, let's do 8x plus, how about 16? Its factored form would be x plus 4 squared. Here's another one. F of x equals x squared plus 10x plus 25. Its factored form would be f of x equals x plus 5 squared. You might be starting to see what's going on here. F of x equals, I'm only been sticking with the positives. We could have had a negative. So let's do x squared minus 12x. That's going to be plus 36. Its factored form would be f of x equals x minus 6 squared. How about f of x equals x squared minus 14x plus 49. Its factored form, f of x equals x minus 7 squared. Hopefully we're starting to latch on here. Let me put one more up here because it's my favorite. F of x equals x squared minus 16x plus 64. Its factored form would be f of x equals x minus 8 squared. All right, hopefully what you're starting to see in these pairs of standard form, factored form, standard form, factored form, standard form, factored form, is that the number here is whatever the b term was divided by 2. Whatever the b term was divided by 2. 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 So perfect square trinomials factor perfect square trinomial factoring. This is going to come down to f of x is going to be x plus whatever the b term was divided by 2 squared. Okay, and the perfect square trinomial itself was x squared plus bx, and then this third term is really that b term divided by 2 squared. Whatever this b term divided by 2 was squared becomes our final term. So negative 8 squared is 64. Negative 7 squared is 49. Negative 6 squared is 36. Positive 5 squared is 25. Positive 4 squared is 16. Positive 3 squared is 9. So whatever that factored term here, that b divided by 2 term squared, that is our last and final term in a factored perfect square, or in a perfect square trinomial. Okay, we are building towards this completing the square idea, which will be trying to make a perfect square trinomial out of any trinomial we've been given. Alright, so let's put this all together. So we'll say we're given this f of x equals x squared plus 12x minus 32. I will tell you right now this is not even factorable, but we're going to make it into a perfect square trinomial so that we can put this into something squared, which will look like our vertex form. Alright, so step 1, make sure we're in standard form. Step 1, put in standard form. Fortunately, we're already there. We got x squared, then our bx plus c. We're all good. Alright, step 2, add c to other side of the equal sign. Alright, so we're going to have x squared plus 12x. We will have minus 32 equals 0. Let's add that to the other side. There goes my marker. Feeling good. Alright, when you do that, I want you to leave a little space here. X squared plus 12x plus something is equal to 32 plus something. We're going to make this part into a perfect square trinomial, okay, which if we recall was, we had x squared plus bx plus the term here was b over 2 squared. B over 2 squared. So to decide what we're going to be adding to both sides of the equation, which we have to do to maintain equality, we'll take our b term, divide it by 2, and square it. That's going to go in both of these sides here. So we're going to do our b term divided by 2, square it, b term divided by 2, square it. So we get x squared plus 12x plus, what is 12 divided by 2? That's 6 squared is 36 equals 32 plus 36. So that step that we just did was we added the b over 2 squared to both sides. Step 3, add b over 2 squared to both sides. We have now made a perfect square trinomial that would factor to, what did we say? That's going to factor to that b over 2 term. B over 2 is going to be 6 in our case, whole quantity squared. So this now becomes x plus 6 squared is going to equal 32 plus 36, which again we had to add this on both sides to maintain that equality. We're allowed to add stuff to equations as long as we do it on both sides of the equal sign, and that's still equal. So these two added up, we get 68. And now our step 4, we're going to bring that constant term back over to the other side. Bring, oops, that's how you spell that. Bring constant back over. So we have f of x equals x plus 6 squared minus 68. I would have subtracted 68 on both sides. And now this is in vertex form. Where's the vertex? That's at negative 6, comma, 68. Et voila. Let's loop back. What were our steps? Made sure it was in standard form. We added the c term to the other side of the equation. We moved that guy to the other side. When we did so, we left a little blank. We then made this into a perfect square trinomial by adding b over 2 squared to both sides of the equal sign, which then factored right into our b over 2, x plus b over 2, all of that squared. That factored to x plus b over 2, all of that squared. And we brought our constant back over to get this into vertex form. Now notice our a value was 1. It's going to work a little differently if our a value is not 1. So let's do an example with that. So here's an example. A is not 1. A is 2. Right? First step is going to be the same. Step 1, put in standard form. We're in standard form. Cool. Step 2, also still the same. Move constant to other side of the equal sign. So we got 2x squared plus 20x plus 81. We're going to subtract 81 this time. So we'll have 2x squared plus 20x plus something is going to equal negative 81. Now this time we should see there's a number GCF that we can take out here. Oh, I need a y plus box over there. So step 3, factor out GCF. But just the number part. Obviously these both have an x in there. We're not going to factor that out. Just the number part. So let's take out our 2 x squared plus 10x plus something is going to equal negative 81 plus something. Alright, so note here, I've got my parentheses right there, so I'm really multiplying 2 times whatever this ends up being. So on my other side, I need to remember to multiply by what we took out here, 2 times that something. So let's put that as step 3b. Make sure to add the factored out term to other side as well. I've got a 2 out here, and I'm going to multiply that 2 by this term. I need to multiply that 2 by this term on the other side of the equal sign, again, to maintain our equality. Step 4, same thing. Add b over 2 squared to both sides. Okay, so our b is now 10. So we're going to add 10 over 2 squared to both sides. 10 over 2 squared to both sides. So we have 2 times x squared plus 10x plus 10 over 2 is 5 squared is 25. And an equal negative 81 plus 2 times 10 over 2 squared. Our 10 over 2 was 5, squared was 25, times 2 is 50, right? And now we can factor this perfect square trinomial. It's going to be x plus 5 squared equals negative 1 plus 50 is negative 31. And we'll add this term back over to the other side. That constant back over to the other side, so we've got f of x equals 2 times x plus 5 squared. This will be positive 31 now. And we're in vertex form. Where's our vertex? Well, that's at hk. So it's supposed to be x minus h, so x minus negative 5. And k is going to be 31. And that's it. Love you so much, scholars. Keep on that hustle. I'll see you next time.